Okay, folks, this is actually in chapter 7 in your book. It's on X-ray production. We're going to talk about that anode that's in the X-ray tube that we mentioned just a little bit ago. Again, chapter 7, X-ray production, electron target interaction. First of all, the electrons that we just mentioned in the X-ray tube are generated from that filament by virtue of the fact that we boil them off. The target interaction, if you recall, the target is actually the anode or a portion of the anode where those electrons interact. So this term, electron target interaction, is very descriptive of what's actually happening in there. Again, if you recall from a few days ago, we had a definition of kinetic energy. Just to repeat that, kinetic energy is energy possessed by a body by virtue of its motion. And what we're talking about, the body we're talking about right now, is the electrons, and the motion is the speed with which they impact that target. We said the interactions result in X-ray energy being produced. And if this is true, the rule of kinetic energy, or the law of kinetic energy, and this, by the way, is the formula for that. If we increase the velocity or the mass, what's going to happen is we're going to end up with more energy resulting from that, which will stand to reason that means that we'll get more X-ray energy out. So basically, if we increase the mass of those electrons, we can get more X-ray energy out. Can we increase the mass of an electron? No, we cannot do that. That's a fixed size, fixed mass. What we can do, though, is increase the velocity by which those X-ray, or those electrons, interact with the target. We do that with that high voltage. Remember that's 150,000 volts that we talked about earlier? If we turn that voltage up even more, then we increase the speed with which these electrons impact that target, and that results in higher X-ray energy. So keep that in mind as we talk about this more too, because it all comes down to how hard and how fast we impact that target with those electrons. Kinetic energy, or KE, is kinetic energy, where M is the mass and V is the velocity, as we talked about earlier. And by the way, kinetic energy is measured in joules. Joules is also a term that we use when we talk about defibrillation in the 212 class, so hold on to that term if you're not familiar with it. To raise kinetic energy of the electrons, or again the energy in motion of electrons, is to raise the kVp. What do you think kVp means? It means kilo electron volt peak. The kVp, kilo electron volts peak, that's the 150,000 volts, or it can be less or more, but 150,000 is typically the number that we use and sort of work around there. It's the high voltage, we call it high voltage on the X-ray tube, that we use to control the speed of those electrons. When electron kinetic energy goes up, the intensity or quantity and the energy or quality of the X-ray goes up as well. It doesn't say X-ray here, but what we're talking about is the X-ray energy that comes out of the tube. And this number 2 bulletin, this middle bullet here, pay particular attention to that, because you're going to see that a lot over the next few weeks. Let's repeat that. When the electron kinetic energy goes up, the intensity, which is known as the quantity or number of, and the energy or the quality of the X-ray energy goes up. Okay, well, again, we'll see that more later. Kilo electron volts are equivalent to joules. When we look at energy from X-rays, the kilo electron volt is a more convenient form of measurement. So again, more about that a little bit later too. Target interactions. We said this the other day. And again, when we talk about target interactions, keep in mind we're talking about the anode inside that X-ray tube. Heat production. The high energy electrons that interact with the anode create mostly heat. When they excite an outer shell electron, and don't worry about that, we'll get to that in just a minute, the electron will not be ionized, but will give off radiation in the form of heat in the infrared range. 99% of the kinetic energy of projectile electrons is converted into heat. So what does that tell you? Is this machine very efficient? No, it's very, very, very inefficient. That's the way of life in this X-ray production. Efficiency of X-ray production is increased by increasing the kVp, which is true, but there's a limit to what we can raise that kVp to in the medical industry. They can raise it higher. They can actually raise it to millions of volts in industrial applications, but we're limited to what we can do in medical world. Okay, just keep that in mind, that most of the kinetic energy produced by interactions from electrons in the target result in heat. So again, we said we have this glass envelope of this X-ray tube encased in oil and surrounded by a metal. That is to help dissipate the heat that's created inside that tube. And by the way, that's also the reason this anode, this target, is rotating. That's why we've got this motor down here. If we didn't have a way to rotate that, all the heat that's generated by this impact right here would burn this up in just a few seconds. It wouldn't last any time. So it's very, very critical that we understand that. Okay, just a little table of how inefficient this actually is. If we applied 20,000 volts to the tube, we would expect to see about 0.5% of that energy converted to X-rays. 99.5% would be heat. 100 kV, we see about 1% actually X-rays. 99% of it is heat. But if we go up to 20 million volts, we get about 70% of the energy converted to X-ray, only 30% to heat. So it's much more efficient to run these X-ray tubes at millions and millions of volts across them. The problem is, again, this is done in industrial X-ray, but it's not done in medical because we don't have the means to control the energy that's produced by it. The radiation that's produced by these machines would do a lot of damage to the human body. So we can't use that for that purpose. So we end up using something in this range right here of about 1% efficiency for our X-ray machines in medical. Okay, the next thing we're going to talk about is Bremsstrahlung interactions, and also we're going to talk about those characteristic interactions. And I've already posted some little videos of that on your Moodle for you last week. Hopefully you got a chance to look at that, and you're probably scratching your head wondering, what does that mean? We're going to talk about that in the next video. Have to shut this one down because we're getting to the point where this is almost too large to upload. I'll be back in a few minutes with Bremsstrahlung interactions.